Modernage MCQs Physics First Year Unit number 6 Fluid Dynamics Part 4. A tank full of water has two identical and opposite small holes at height 0.3 meter. If the speed of efflux from right hole is 9.8 meter per second, then the speed of efflux from left hole will be option A 4.9 meter per second, option B 9.8 meter per second, option C 19.6 meter per second, option D 39.2 meter per second. The key is 9.8 meter per second. Therefore, the correct option is B. Reason: the speed of efflux is V is equal to 2G h square root, where h is the depth of a hole. The holes are at same height, which is 0.3 meter. Therefore, the depth of both holes is same and speed of efflux is also same. Therefore, the speed of efflux from left hole is also same, that is 9.8 meter per second. Hence, the speed of efflux from left hole is 9.8 meter per second. Pascal second is the unit of coefficient of viscosity, where 1 Pascal second is equal to option A 1 kilogram per meter per second, option B per kilogram meter per second, option C 1 kilogram per meter second, option D 1 kilogram per meter square per second. The key is 1 kilogram per meter per second. Therefore, the correct option is A. Reason: 1 Pascal second is equal to 1 Newton per square meter into second. But Newton is equal to kilogram meter per second per second. Therefore, 1 Pascal second is equal to 1 into kilogram meter per second into per square meter into second, which is equal to 1 kilogram per meter per second, because 1 Newton is equal to 1 kilogram meter per second per second. Hence, 1 Pascal second is equal to 1 kilogram per meter per second. The unit of coefficient of viscosity is option A 1 kilogram per meter per second, option B 1 Pascal second, option C 1 Newton per square meter second, option D A, B and C. The key is A, B and C. Therefore, the correct option is D. Reason: 1 Pascal second is equal to 1 Newton per square meter into second, which is equal to 1 kilogram per meter per second. Hence, the options A, B and C are units of coefficient of viscosity of fluid. 10 poise of viscosity of fluid is equal to option A 1 kilogram per meter per second, B 1 kilogram meter per second, C 1 kilogram meter per meter second, option D 1 kilogram per square meter per second. The key is 1 kilogram per meter per second. Therefore, the correct option is A. Reason: 10 poise is equal to 1 Pascal second, which is equal to 1 into Newton per square meter into second, is equal to 1 kilogram meter per second into per square meter second, which is equal to 1 kilogram per meter per second, because 1 Newton is equal to 1 kilogram meter per second. Hence, 10 poise is equal to 1 kilogram per meter per second. 1 centipoise of viscosity of a liquid equals Option A, 10 power minus 3 Newton meter square per second. Option B, 10 power minus 3 Newton second square per meter. Option C, 10 power minus 3 Newton second per square meter. Option D, 10 power minus 3 Newton second per meter. The key is 10 power minus 3 Newton second per square meter. Therefore, the correct option is C. Reason: 1 centipoise is equal to 10 power minus 10 divided by 10 Pascal second, which is equal to 10 power minus 3 Newton per square meter second, which is equal to 10 power minus 3 Newton second per square meter, because 10 pi is equal to 1 Pascal second, and 1 Pascal is equal to 1 Newton per square meter. Hence, the 1 centipoise of viscosity of a liquid equals 10 power minus 3 Newton second per square meter. Water is flowing through a level pipe from narrow to wider cross section. The pressure, option A, decreases, option B, increases, option C, remains same, option D, becomes 0. The key is decreases. Therefore, the correct option is A. Reason: from equation of continuity, A V is equal to constant, where A is the area of cross section of the pipe and V is the speed of the water. We have V is proportional to 1 by A. As the area of cross section A increases, the velocity V decreases, because velocity is inversely proportional to the area of cross section, and corresponding pressure P increases according to Bernoulli's equation. P plus 1 by 2 rho V square plus rho G. H is equal to constant. In this case, H does not change, rho does not change, but V is decreasing, therefore P is increasing, so that the sum of pressure plus kinetic energy per unit volume plus potential energy per unit volume remains constant. Hence, the pressure decreases. The Stokes law is applicable in fluid to the motion of A. Option A, ring. Option B, disc. Option C, sphere. Option D, cylinder. The key is sphere. Therefore, the correct option is C. Reason: the Stokes law, Ft is equal to 6 pi eta Rv, is derived for a spherical body of radius r moving with velocity v in a fluid of viscosity eta. Fd is the dragging force. Hence, the Stokes law is applicable in a fluid to the motion of a sphere. A net force will act on a 16 Newton falling object if air offers a resistance of 6 Newton. Option A, 6 Newton, option B, 10 Newton, option C, 16 Newton, option D, 22 Newton. The key is 10 Newton. Therefore, the correct option is B. Reason: the resistance of air opposes the motion. Therefore, the net force that acts on the falling object is Fn is equal to 16 minus 6, which is equal to 10 Newton. Hence, the net force acting on the object is 10 Newton. For the fluids, the ventimeter is used to measure. Option A, pressure. Option B, viscosity. Option C, density. Option D, speed. The key is speed. Therefore, the correct option is D. Reason: the ventimeter is a device used to measure the speed of flow of fluids. Hence, The meter is used to measure the speed of fluids. A leak point is 10 meters below the surface of water in a tank. The speed of water emerging through the leak is option A 14 meters per second, option B 10 meters per second, option C 9.8 meters per second, option D 4.9 meters per second. The key is 14 meters per second. Therefore, the correct option is A. Reason the speed of efflux is VE is equal to 2G under root, which is equal to square root 2 into 9.8 into 10, which is equal to square root 196, or VE is equal to 14 meters per second. Hence, the speed of water emerging through the leak is 14 meters per second.